Imagine starting your day, walking into your office, and realizing your entire morning administrative workload is already finished. You haven't even touched a keyboard. While you were asleep, your AI reviewed your meeting agenda, drafted the necessary follow-up emails, booked an open conference room, and caught a scheduling conflict for tomorrow afternoon. Most artificial intelligence currently operates on a reactive loop. You type a prompt, it generates a response, and then it stops, sitting idle until you provide the next specific instruction. We are now seeing the arrival of Agentic AI. These systems are designed to take an initial objective and see it through to completion without waiting for further human input. To understand the difference, think of traditional AI like a standard calculator. You punch in an equation, and you get an answer. Agentic AI operates like a project manager. Software is evolving into a digital worker, a system that accepts a high-level objective and manages the execution itself. The core of this autonomy lies in how the system processes an initial request. When given a single master objective, an agentic system independently breaks that large task down into a sequence of its own manageable sub-goals. To complete those goals, the agent reaches outside its own isolated chat window. It connects directly to the digital environments we use every day, opening web browsers, accessing code editors, and pulling data from external APIs. As it navigates these tools, the system executes multi-step logic. If it encounters a broken link or an unexpected error in a database, it evaluates the problem, pivots, and makes a new decision to keep the workflow moving. And when an objective becomes too complex for one process to handle, the main agent can write instructions for and spawn entirely new specialized sub-agents to take over specific pieces of the puzzle. We see this operating in software development right now. Autonomous agents take high-level feature requests, write the necessary code, run their own tests for bugs, and push updates directly to GitHub. In customer service, these systems manage support tickets from the initial complaint all the way to final resolution. In scientific research, they are designing experimental parameters, analyzing the raw data, and suggesting the next logical area of study. AI has broken out of the sandbox. It is actively embedding itself into the core operational workflows of modern enterprise. A few years ago, early open-source experiments like AutoGPT showed the tech community that these autonomous looping behaviors were technically possible. That proof of concept sparked the current enterprise arms race. This chart shows the projected financial trajectory of the agentic AI market over the current decade. Driven by massive influxes of venture capital, analysts expect this sector to expand into a multi-hundred-billion-dollar market. The largest players in the industry, companies like Microsoft, Google, Salesforce, and ServiceNow, are completely pivoting their long-term roadmaps to prioritize agentic integrations. These companies are re-architecting their software ecosystems, positioning AI agents as the primary interface for completing work within their platforms. Because these major platforms provide the foundation for modern office work, their move toward agentic systems will likely set a new standard for how business is conducted. Handing over the steering wheel introduces a new layer of friction. Granting a machine true autonomy inherently injects compounding risks directly into daily operations. On a purely technical level, running continuous multi-step loops requires a massive amount of computing power, which drives up operational costs. There is also the persistent reliability issue of agents losing their context and veering entirely off track. Giving an AI live access to databases and customer APIs means a single autonomous error can cascade into genuine, widespread damage. If a system makes a disastrous choice on its own, it raises immediate questions about who is legally responsible. To mitigate these dangers, developers are building strict human-in-the-loop checkpoints, where an agent pauses its workflow and requires explicit approval before executing a high-stakes action. The industry is also racing to establish standardized reliability benchmarks to prove these systems are safe for deployment. We are watching a shift in the definition of labor. The primary challenge now is not whether software will learn to act on its own, but how quickly you can prepare your industry for its arrival. If you found this breakdown useful, please like and subscribe. Next episode, we take these autonomous systems out of the computer and into the real world, exploring the edge of physical AI and robotics.